very excited to have the North American Eagle team here with us at the Museum of Flight. For me personally, I've just been fascinated by this entire idea of taking an airframe and turning it into a car for a long time, and so this is great. So to get everything started, I would like to introduce to you Ed Shadle. Ed is co-owner of North American Eagle. He's also its primary driver. The vehicle has done 34 test runs. He's driven every single one of them. Remarkable on a number of levels. It's gone up to 400 miles per hour so far, with the goal ultimately of 800 miles per hour. And Ed has driven every single one of these, all the more remarkable because today is his 72nd birthday. So happy birthday, Ed. I won't sing happy birthday to you. I won't lead you that. We can do it at the end if you like. Just to give you a little bit of background on Ed. Ed is an Air Force vet going back to the 1960s. He worked in crypto maintenance, which he described to me as working on secret things. He then spent 31 years with IBM as a field engineer and has been racing things all his life, going back to soapbox derby racing when he built his first soapbox derby racer at 14, I think he said. And he has family members who are stock car racers, that type of thing. He did Civil Air Patrol as a kid, wanted to be the next Chuck Yeager, and I think he kind of blended those two together, car racing and breaking the speed of sound, all in kind of one fell swoop. He started the North American Eagle project back in 1999, and so all of what you've seen outside and what you'll hear about today is a culmination of about 14 years worth of work. And you're going to get a whole overview of the entire project today, and Ed's going to start everything out, and he can introduce our other speakers. So would you please join me in welcoming to the Museum of Flight North American Eagle and their head honcho, Ed Shadle.
Thank you. Well, I want to thank the Museum of Flight for having us here. And of course, I see some familiar faces out there. In fact, a couple of my classmates from high school are out there. So they hadn't heard me speak since 1960, I think. So they're kind of hoping I will have improved a little bit. In fact, I think we were in Latin class together too, weren't we? Yeah. Weenie, weedy, weeky, and all them things. Anyway, yeah, North American Eagle is a project we started a long time ago. I started going to the Bonneville Salt Flats in the 80s and decided that going really fast in a car was a cool thing to do. So, that's kind of, the impetus behind getting us to do this crazy thing. So, along with that, early on, Keith Zangi and I were involved in a previous project. So Keith and I, we came up with this crazy idea to use an airplane to build a car. So that's kind of where we started. And then, it sort of goes on from there. See if this thing works. Well, now we surrounded ourselves with quite a team. They're not all here, but most of them are. And of course, because this is a working session, we weren't all in uniform, so some were, some weren't. But any of these kind of projects, as we all know, they won't work if you don't have a good team around you. This is an all-volunteer project because we're not well-funded, so they kind of have to pay their own way. Keith and I do the best we can with funding, but you can't do it all. So there's a lot of times we go off on these test sessions and the guys pay their own way, pay for their own motels, meals, and all that. But at the same time, the funding basically comes from Keith and myself and the support of a few others. But again, if you don't have the confidence in your team and the confidence in the equipment that you have, you're never going to go anywhere as far as high-speed stuff. And I don't care whether it's airplanes, cars, or whatever. So having a really good team and the support of your spouses and girlfriends and others also works. I like to tell the story about when we first got the Beast, we brought it home and it was a big pile of junk. And our wives and girlfriends came out to look at this thing. And I remember Keith's father saying something to him like, "What are you thinking?" And then his girlfriend left him in 2 weeks. So sometimes some good comes from these things too. He now has a really nice girlfriend, but he's still single. So now I'll cover a little bit about land speed racing. There's airplane racing and there's car racing and all that. There's different venues. This isn't quite like NASCAR or Formula One or any of those. Land speed racing is going as fast as you can over a measured mile. And to make it an official record, you have to do the measured mile at maximum speed, and then you have 1 hour to reverse and go the opposite direction. And it has to be on a certified course with certified timing systems and the proper authorities to validate the record runs that you make. So it's not an easy thing to do, and we all know that there's been really smart people ahead of you. So you're really going after some tall numbers because those guys have worked hard to already set a record. Now we got to beat the guys that are smarter than us, or at least prove to them that we are now smarter than they are, or luckier, either one. You can see from here we have, if you look at the, let's see if this pointer works. I was told with the great green thing not to point at anybody's eyeball, so I'll try not to. But up here, this is all wheel-driven records, and you can see how fast they've gone up to about Mach 0.7. And those are cars that are, they have to be driven by either turbine or reciprocating engine power through a drivetrain and onto wheels. And of course, we're competing over in this category here, which is all thrust-powered. And you can see the significant difference in the records as far as the speed categories. Here's a typical wheel-driven car. Well, maybe it's not typical. Don Vesco was shown, he ran 478, it was his best pass with this, with a turbine engine, wheel-driven. Very fast car, and he'll be back this year. Actually, he won't. His brother will be back with the car. Don passed away from cancer a few years ago. But his brother has resurrected the car, and he's going to try and be the first over 500 with a wheel-driven car. And then again, coming over here to our side on the thrust, you'll see some of our thrust-powered vehicles that we've had to compete to take the records away from. And going way back when, you get everybody knows all about Craig Breedlove and the era of the 60s when you had Arfons and those guys all running against each other. And then along came Gary Gablich around, what was it, 1980 or 81, and he with a rocket-powered car, and he ran 600 and some change. And then Richard Noble established a record in 83 at 633. And again, so now we're getting into rocket and thrust that are pretty significant horsepower off of those. And then the one that holds the current record is the Thrust SSC with a twin-engine car that was built by Richard Noble and driven by Andy Green. And they did that record in 1997. So it's a tall number. We know that. Going Mach 1.01 is that's a big number. But we expect that we can achieve that plus. So we took a different approach, and this is where Keith and I are coming back on a flight from California, and we were brainstorming and says, instead of building a car from scratch, we're really not very good mechanics that way, Although now we have Jessi Combs on board, she's our certified welder. But so instead of going that way, we decided, why don't we go and use an airplane? So we had to kind of argue, what's the best airplane to use? Well, the F-104 Starfighter was small and very fast. I said, let's go with that thing. So we did. Well, we happened to find this thing here, but when we found it, it was a real thing. It was about 2 weeks away from becoming a beer can. So we took this thing, we paid, I think, $25,000 for it and had it shipped out from Maine, where it had made a stop over, because it started off its life out at Edwards Air Force Base, and then wound up in the aircraft junkyard and then sold to different owners, and then it wound up being sold to this guy in Maine who's going to turn into either a pedestal queen or just junk it out. So we wound up buying this thing and hauling it home. Well, you can see up here by the tail numbers, 763. We didn't know any real significance of that just yet, other than the fact that it must be some deja vu, because the 763 happened to be the land speed record, and the tail number of this aircraft is 763, so we said, got to be something to it. So when I was cleaning paint off the thing, I found the ghost letters of FG763, and the data plate was still on the aircraft, serial number 1051. So I wrote a letter to, I think it's Maxwell Air Force Base, where they keep all the archive records on aircraft. So they sent me a list of the life of 763. It was delivered to Edwards Air Force Base in August 29th, 1957, and it resided there at Edwards until 70, when it was sold or sent to surplus at DRMO. And then it got sold as junk. But along with that, we posted on our website and found that a fellow down there at NASA Dryden, Tony Landis, he had pictures of our airplane. So he called me and he says, "You want some pictures of your airplane when it was flying?" I said, "Of course." So he sent us some really neat pictures. And here's, here was on loan for 1 year to General Electric developing the J79 engine. Here it is, Pete Knight was flying it that day as a chase aircraft. Joe Engels was in the X-15, and they just come back from a near orbital flight with the X-15, and Pete Knight was the number 4 chase on that particular flight. Here it is sitting back here. It's used as an escort aircraft on the XB-70 project. And I was talking to Bob Gilliland, who was flying that the SR-71 that one day, and he says, "So guess what we were doing?" And I says, "Well, you're flying?" He says, "We're drag racing." He says, "We're seeing who could fly to specified altitudes the quickest." And he said, "It's just part of the testing program that we're doing." And so we were just really super excited. Here it is again with the XB-70. So yeah, it's just having an aircraft like that with that history to us was just really significant. Then the last time I was down at Edwards Air Force Base talking to the commanding general, he says, "You have a piece of history, so you don't dare wreck it." So okay, we promise we won't wreck it. So anyway, so from there, why don't I roll over into the next phase here. Now, Keith Zangi is my business partner, and he's also a senior manager at the Boeing company, and he's also a drag racer, and he's a pilot and all kinds of stuff. Following him will be Steve Wallace, who is our data acquisition engineer. Steve his degree is in, I think, electrical engineering, I believe. He used to work for NASA and now works for Boeing. And then followed by that will be Brandon. He's one of our younger team members who has taken us into the 21st century as far as our social media and our website material that we have. Because the first time he came to see our project, he was on the robotics team, first robotics program. And Keith brought him to the hangar one day to look at our program. And so I asked Brandon, I says, "So what do you think of our website?" And he says, "You guys need help." And he was only 14 then, and he recognized a weakness. So he'll be talking to you a little bit about our social media and our website and how it relates to what we do. And then he'll hand it back to me and we'll do the wrap-up. So, Keith, you're next.
Thank you, Ed. Is the mic on?
I think so. Can you hear me back there?
There you go.
All right. So Ed was talking about Steve's degree. Brandon's working on his high school degree, but he's kind of in this Head Start program, so he goes to high school and college, and so when he graduates from high school, he'll also get his AA degree from Pierce College. So great job. So Ed mentioned that the North American Eagle was built in 1957 in August. And back then they didn't have computers. It's looking around here. How many people here under the age of 34? We got a young man up here, a few people up here. So we used to go to all these conferences. Ed and I have spoken all over the United States. We've spoken in Paris. And I was a math major from Seattle University. And so I actually had jokes on slide rules. And so I would tell my slide rule jokes, and no one would laugh. Similar to this. And it turned out that when we said this one time, we were speaking in Ypsilanti, Michigan, nice town, and I said, well, listen, nobody laughed at this great slide rule joke. And so I had turned the lights on, and it was a big company here, Tata Technologies. And I said, okay, I did the 32 age, and it was like everybody in the room was like under the age of 32. There was like 10 people. So that's when Ed and I started bringing slide rules. We didn't bring one today, but we actually put photographs of slide rules so they would know. But the reason I bring this up is because the entire aircraft was built on drafting tables. Here's a picture of the Lockheed Engineering Group. And it was built, the head engineer was Kelly Johnson from the Lockheed Skunk Works. He was the guy that developed the SR-71, the F-104. In fact, I think they developed the F-104 from paper to a flying aircraft in 6 months. 6 months. And so what we do now with technology, we're kind of lucky, right? Over here in Redmond, there's a small company, and through their help and some other people, we use computers. And so we use Lenovo ThinkStations and ThinkPads. In fact, we've got a couple workstations that we do our computational fluid dynamics on that have over 48 gigabytes of RAM to do our computational fluid dynamics. So these are really high horsepower computers. It's like having a top fuel dragster in your home office. So I'm going to talk to you today about a couple engineering things. So the first is wheels. And so we design our wheels in the computer. We use two software programs, CATIA and SolidWorks. I think this one is CATIA. Yeah, this one's CATIA. So we start in the computer. Then we do finite element analysis to see if we're as smart as we are. And it turns out in this area here, anything in blue, in fact, everything's in blue, that's a good sign. If there was some oranges in there or reds, that means it's getting into some key critical areas that could have problems with engineering. So we do the FEA, and if the FEA looks good, then we can go forth and actually design the inner parts. Like here's the, shows the bearings, the steel part that the bearings mount on. This here is a rotor. We'll talk a little bit about that in a little bit here for our brakes, our magnetic brakes. Here's the rotor for the magnetic brakes. Again, here we do FEA on the rotors. Blue is a good sign. You see just a little bit of red here. This is one of the earlier designs. We actually have a different design now that's even better. So then you take this data from the computers, you throw it through another software. We use IMS software and converts it into machine code, and you can put it on an NC milling machine and make the finished product. In the old days, this would take, a really good machinist, and it would take a long time. Now you hit a button and it pops right out. So I want to talk to you now is something unique on the North American Eagle. It's the only vehicle ever built with magnetic braking. Now we didn't bring it to the museum and put it on display, so I'm going to show it to you here. But in the back, on the two rear wheels, are some large magnets. This black device here is a magnetic pack that's made out of neodymium iron boron rare earth magnets. Now every one of you has one of these in your computer on the hard drive, okay, but it's real small. This particular one, if you were to get this magnet onto a piece of steel, would take 20,000 pounds to remove it from the steel. So you see this gap here, it's about 1.5 inches. What we do is we close that gap with that rotating rotor that I talked about earlier, and you create eddy currents in the aluminum. And that creates resistance. So the only byproduct is heat. So in this case, this was an older design here where we're measuring the heat. So we have temperature gauges in the cockpit, and we have a water system that cools it down. But these brakes here generate quite a bit of horsepower, 4,700 brake horsepower. So it's kind of unique too because we can apply right or left independently and use that to do independent steering on the car. So now I'm going to talk to you a little bit about the aerodynamics. We're not going to get real technical here. We're going to talk really at being in a Air and Space Museum. We can talk at the 50,000 foot level, and most of you know what that means. So we do a lot of computational fluid dynamics. Computational fluid dynamics, or CFD, is a study of fluids. In this case, we're studying the fluids around an airframe, but you can also study the fluids around bolt holes like the America's Cup boats, or even the blood flowing through your heart. Okay? And so here, these are what we call free streams. Areas that are blue is where the air is slowing down. Areas where it turns red is where the air is speeding up. And so you'll notice on this here, we've got a little bit of red here, and just behind the inlets, this is at Mach 0.8, which is around 635 miles an hour. And so those are the areas where we're going to start generating localized shock waves. So this shows another graphic showing those shock waves where they're going to develop on the ground when we're traveling. So the blue area is pretty safe, but right here, right by the canopy where Ed's sitting, right by the inlets, and then also in the back when we start getting higher speeds is where we're going to start generating those transonic shock waves. Now, Ed and I made a trip to Dryden, many trips to Dryden down at Edwards. And on one particular trip, we asked him, what kind of data do you have on transonic shock waves? These are the shock waves where eventually it turns into a supersonic shock wave and creates a sonic boom. Well, these are really big pressure waves, and so we're really concerned about it. And they said, we've got warehouses full of data on transonic shock waves. And then they asked Ed and I what the application was, and we said a supersonic vehicle 6 inches off the ground, and they had nothing. And so this is kind of an R&D project working out of Spanaway, Washington. So we've been studying the flow of and the effects of transonic shock waves in a ground plane. Now this is really important because if that shock wave builds up too much under the car, it can blow over like one of these unlimited hydroplanes, and Ed had a problem with that. So we'll do here, this is another tool we use. You can actually study the cross-section of the air flowing at any point on the vehicle. Here's another type of graphic. Again, now you can really see the pronounced shock waves taking place. This, remember, is at Mach 0.8. Okay, so we haven't even gone Mach 1 yet. So you're generating right above the canopy, just behind the inlet, and then back here. This also tells us we have a huge, gigantic drag problem. In fact, in the present configuration, you see here, this was an earlier configuration. We've since changed it. We had a top speed, no matter if you put an engine off of a Saturn V, well, maybe a Saturn V would go, but the jet engine we have now, we had a top speed of 698 miles an hour. There was no way it was going to go any faster. And so we knew we had a problem, and so we've done work now to get us to the speed that we're trying to achieve, and that's to break the 763 mile an hour barrier. So some of the things you do is, oh, this seems to work better when I talk in the mic, is the airflow over the axle. You can see that. This is kind of looking from the bottom, also covering up the parachutes in the back, and putting these devices in front of the wheels. Now, this is one of the earlier designs, and so we're still working on that. So now I'm going to turn it over to Steve Wallace, who's going to talk to you a little bit about data acquisition.
Okay, good. Hi. Keith was talking about transonic shock waves and how important it is to understand what happens when we're going that fast. And so I didn't know this when Keith got me involved with this project. He says, I've got this little project I'm working on. And I was down at his facility there in Boeing. And he saw me putting sensors around inside the factory. He was measuring some noise. And he says, I need some data collected. Sure, I'll help you out. Well, what weekend are you available? Well, next weekend's good. So I come there, and that was, let's see, how many weekends do we have in a year times 52? 8 years of that. I've been there quite a bit, and I didn't know that we were going to have to deal with something that looked like that. It wasn't very pretty. I didn't know that there wasn't anything already made in terms of data collection, or we didn't have sensors, we didn't have any electronics, we barely had any anything. It had to be pretty much made from scratch. The other thing he didn't tell me was that we had some environmental problems to deal with. This is a real picture of, there's our data acquisition team right there, readying for the next test. This is not fog, this is dust. And it kicks up out in the desert pretty violently sometimes. And I didn't realize that we'd be up late at night in sub-freezing temperatures working on electrical systems and trying to get something to work that wasn't working correctly. Didn't realize that it was going to be 118 degrees, and I had to have electronics working at that temperature and collecting data and not having computers crash when I didn't want them to. I found out the hard way that you cannot cool a computer with hot air. And we have extreme vibration. Problems for things that have hard drives that can't bounce around. We also have a problem with connectivity, because I can't just chase alongside this vehicle at 800 miles per hour with a long extension cord and try to collect data. I had to figure out how to do all this data collection remotely. First things first, let's solve the temperature problem. I ended up going down to the aerospace department at Home Depot and got a bucket and some great stuff and some refrigerator tubing and made a heat exchanger that we put in the back to cool the computing system. This is an early home-brewed computing system. See, we were sponsorless back then. I had to make the computer from scratch. I got the motherboard and the hard drive and the chips and all, and got the heat exchangers, and we threw together this in a Pelican case and chilled it with water. We've grown since then. We now have a solid-state hard drive with a laptop with a solid-state drive. We have a fancy data acquisition system from National Instruments, and we have a global navigation satellite system that we're using to do the tracking. And this is all on a shock mount inside the vehicle. There's a fuel pump converted, it's pumping glycol through my laptop to cool it. Here we have aero sensors. Now, as I was starting to say, Keith mentioned that transonic shock waves can be a problem. They can be a real problem, not so much sonic above the speed of sound, but it's passing through the speed of sound. We get instability because we get shock waves happening some places and not in others, and because that's not a symmetrical, necessarily symmetrical vehicle, we need to understand what's happening. So I have those tubes that you saw that were, let me go back here. There we go. These tubes here go down to a sensor box here, and we are collecting data. All these red dots represent places where I have these tubes going to, where I'm collecting data on air pressures during the runs. So we can compare that with our computational fluid dynamics model, so we know that what we're predicting is actually happening in the real world. In addition, I've got accelerometers, and those are devices that measure acceleration. This is a special accelerometer that's mounted right here on top of one of the mid wheels, and it is rated plus or minus 10,000 times the force of gravity, because I shook to death a couple of accelerometers that were rated at a couple hundred Gs, and the PCB company gave me some top secret accelerometers that I can't even bring those outside of the country. I had to sign papers that I wouldn't do it. So there it is, and you can see the conditions, the dust. Oh my God, you're trying to get delicate electronics to work in this environment, and it's been an extra special process. This is an animation. I made this model, this computer model, and then took the data from the accelerometers that I had about the vehicle and applied it to my model to see and understand how the vehicle moves as it's running down the course. And I won't let this thing run forever, but we are able to see, we can see what's bouncing up and down, and we can see, this is not in real time, this is after we've downloaded the data after the run. We can go back and look and see what really happened. It's been a good tool. And one of the most valuable tools has been using GPS technology, but we're using a special kind of GPS technology. It's called Global Navigation Satellite System, and it is extremely accurate. We're able to track the vehicle, take data, its position 20 times a second, and the positional data is accurate within 5 millimeters horizontally and 3 millimeters vertically. So we're able to convert that position data into acceleration and speed. This is a screenshot of the computer as I'm sitting in my Subaru monitoring the on-screen computer on board with Ed wirelessly through an Ethernet, wireless Ethernet. And we're tracking 20 satellites simultaneously. We've got 10, I didn't count, 1, 2, 3, 6, got 11 GPS, and looks like 10 Russian satellites. And we get, all that data is combined at once, and that's how we're able to get that plus a stationary ground station that's taking simultaneous data. It does a subtraction, and we're able to get extremely good accuracies and high data rates. Now, one thing I want to touch on quickly, because I don't want to hog all the time, but we had to validate this. I didn't know. I had to write the software to do the conversions for all of the GPS location. And so we had to put it in a vehicle and run it against something we knew that was true. So we went down to Bonneville, put it inside this vehicle here, and ran it down there. This is our stationary system, the comparator, the static system. And there's one on the inside of this vehicle. Here's the antenna. Here's the board that I got from the company as a original equipment manufacturer sample. And gave me the board and I had to figure out how to use it. Ended up having to break it in half and put it in this aluminum case. I learned all about wire wrap. I don't think anyone here knows what wire wrap is. He does. Good. Thank you very much. Yeah. There's 100 different connections I had to make with a wire wrap gun. Anyway, we loaded it in there and we ran it, and the results validated what we had, the GPS system and the official system down at Bonneville. They're right on. We agreed. And this is the car that we raced in, and Ed, it was the last driver who holds the record at 276.786 miles per hour in that C-class powered open-wheeled Lakester. So he still holds the record. Now, he wasn't driving when we did the validation. Calvin was, another one, a driver that we know well from Canada. I mentioned the Ethernet. That's a whole story in itself. We could talk for an hour on how we were able to do this, but we have towers. This is the tower in my backyard. That's when the neighbors started calling the police and wondering what was going on, who's setting up something in the backyard. No, but they were asking questions. We had a tower made out of a forklift out in the desert, and now we've graduated to a point where we're erecting these towers every 2.5 miles down the course, a mile offset from the course for safety, and we're able to maintain connectivity with the car throughout the entire course, except when it's running really fast. Then we don't have good connectivity, but we need a system that can heal itself quickly when the car gets slow enough that it will work. And this has worked out really, really well. This is just a chart showing, this is Edwards Air Force Base. That's the space shuttle runway, and this is the plan for when we were contemplating going out there. This is what we showed the Air Force what we were going to do. And it's pretty much the same setup that we have on our other race tracks, where we have periodic towers, we've got batteries supporting all of this, and I have windmills keeping the batteries charged. And now we're going to hop over to Brandon Baines, and he's going to tell about the more modern aspect of this project.
Well, good afternoon, everyone. Is it on? Yep. So, like Ed said, I came to this project 2 years ago, and he asked me, what do you think of our website? Well, I told him it could maybe use a little work. So I want to talk about 3 things today that North American Eagle team is doing a lot with. So here's what we're going to talk about. We're going to talk about first the website, okay? This is recently redone. We're also going to talk some about our mobile apps. And finally, we're going to talk about our social media presence. Those are 3 things we're going to cover. So let's start off with the website. So the website, originally it looked something like this. It was white, it was very constrained, it was hard to navigate. I'd heard all sorts about this on, they wanted to do something a little bit different. I told them we could do that, and we did. We completely redesigned the website. We started using higher quality images, easier navigation, and today it looks something like this. We've brought in all sorts of brand new features. It looks absolutely incredible. It's easy to use. You can load it from any mobile device just about. Just absolutely incredible. So let's talk some about our mobile apps. Now, in the last couple of years, mobile apps have become incredibly popular. And of course, we wanted to stay ahead of the technology curve. So we decided to start building a mobile app, and we did. And it looks absolutely awesome. You can load up all our project updates, you can read about the team, what we're doing. The app is constantly up to date, so you're never behind on information from our website, and you can get it from just about anywhere. We've also got it at working on iPads, Androids, just about anything. And just to give you an idea of how this has really taken off. In the last year, when we launched our apps, currently we have 380 some users on Apple devices. We have 106 Android users, totaling us out to over 480 active users. Now on top of this, in just about any given month, we average over 3,000 people visiting our website. So, and then social media. Social media is a part of a lot of people's daily lives, so of course, we want to be a part of that as well. So, as of today, we're on Facebook, Twitter, Google+, and YouTube. Now, just to give you an idea of our expansion. So on Twitter, initially, we had very few users. Today, over 150. By email, currently, we're totaling almost 500 users. And that's people that are consistently receiving emails and information from us. And finally, almost 850 people are consistently receiving information and through Facebook from us. And just to give you an idea of what we've really done with social media. So this year we did an engine test. For those of you that follow the project, I'm sure you heard about it. We had it all over our website. And so over a 3-day span, we measured how many people saw what we wrote about the engine test. So in that 3 days, we reached over 3,000 people on Facebook, over 1,500 via our website, and over 500 by Twitter. Totaling out, we reached over 5,000 people in a single 3-day span. It's absolutely incredible. Now, there's just one more thing. So, over the last couple of years, we've reached into all these different places. And so I started thinking, what is the next thing that we need to start doing? So I was reading through some messages that we've received through our Facebook page. And someone said, you know, it'd be a great thrill to take this out and go drive it. It's like, heck yeah, that would be a heck of a lot of fun. But I'm pretty sure Ed's not going to let very many people drive that. So, what's the next best thing? Well, a lot of people have smartphones. They've got some sort of electronic device. So what we're introducing NA Eraser. You can go drive North American Eagle from your smartphone. And for those of you that are wondering about it, it's available on Monday. You can go to our website. We've got all sorts of information about it. And so at this time, I'm going to turn it back over to Ed. Thank you all for being a great audience. There you go.
So, needless to say, Brandon surprised us all when he came there as a 14-year-old and took one observation of our operation and says, I think I can help you guys. And so it really has taken us into the 21st century when it comes to social media. So next steps. Well, the next step we're going to be taking, of course, we mentioned going down to Texas for the National Instruments National Conference. We'll be on display down there, and Keith will be the keynote speaker on our behalf in front of the main tent, which will be about 3,000 or 4,000 engineers with a 100-foot Jumbotron screen. But don't let that bother you, Keith. It's, you know, I know it's intimidating, but yeah, I think you can handle it. He does his best jokes in front of 4,000 people. So, but then when we get back,
That's why they were so crummy today.
Yeah, the more the better. Then the next steps we'll be doing when we get back from Texas, we'll be doing some final work on our aerodynamics and some of the fairings and that kind of work. We may do a one-day engine run out of Shelton just to verify systems that we need to make sure, absolutely sure are working. And then we'll haul out to the Outboard Desert. I just got the permits yesterday that allow us to go out for the month of October to run at the Outboard. So the BLM approved our permit request. So we'll be there first couple of weeks, and we'll be doing some pretty significant testing at that time. Seeing how it handles up to around 600 miles an hour. We've only run to 400, so we'll squeeze it up around 600. And then as soon as we get back from that, we have about a 2-day turnaround, then we put it in the Seattle Auto Show. So we'll be up here for that. And then we've heard that we may be approved for the Detroit Auto Show. So the reason we do those shows is really to help try and find a sponsor that will give us some financing to make this happen, because obviously this, it's a really tough deal when we're out selling pencils on the street corner to try and make ends meet. But that's what we have to do. But anyway, the Outboard Desert, in case some of you folks are interested in knowing where that is, it's 130 miles out of Burns, Oregon, to the southeast. Last 28 miles of it is gravel road, but don't let that intimidate you. We stay at the Outboard Ranch as guests of the Paul Davis family, and we stay on the old ranch in the ranch bunkhouses that the cowboys normally live in. It's a 250,000 acre ranch that's worked in the old-fashioned way with off horseback. So it's really quite an adventure just going out there in itself. But if any of you have never been out to a desert that is that lonesome, it is also the most wonderful experience. I mean, you get to sit there at night and listen to the coyotes howl and all that stuff, and it's really quite an experience, a lot of fun. And so here's one of the, I can't remember what we were doing there. We were towing the thing around in the lake bed, I think. Actually, what we're doing on that one is we're calculating the drag resistance on the vehicle on that lake bed, so we can calculate some rates of acceleration and deceleration. But that's on the Outboard lake bed right there. This is also Outboard, our session that we did last fall. We unloaded on Sunday, got our pits all set up. Monday morning, we were expecting to go out and start some runs, and it started raining about 5 in the morning, and by 7 or 8 it started snowing. And we sat in the snow all week long, and it was a real mess, as you can see. The mud sticks to your feet like gumbo, and the snow was really pretty, but that's all. So it was quite an adventure that week. We finally did get a couple of quick little runs on a short piece of territory we were able to find on Friday, so it wasn't a total loss, but we did get some runs in. You can see some of us having a great time there on the back of a truck with we finally hitched a ride off of the lake bed because our feet were getting bigger and bigger. Here's a typical layout. This is at the Black Rock Desert with our great big hay tent and the semis and all the equipment that we lay out. It looks like a circus coming to town for sure. It takes us about a day and a half just to set up the shelter. So when we go out there, we have to make sure we've got our program together. We have a reason to be there. We have a test program. We know what we're going to do, and we have certain expected results. So it's a major operation and a very serious undertaking as well. Now this here is always fun. Okay, everybody have your earplugs. This is one of our afterburner runs. This is the one we just did recently down at Shelton. And we go out there, and the folks at the Port of Shelton, they buried 3 of these 2,000-pound concrete blocks about 6 feet down with chain and stuff to hold us in one spot. And so we're able to actually do full engine runs and full power in and out of afterburner without the fear of, like when we ran a span away, we used to try and pull a tree out of the ground, so we don't do that anymore. So we'll do a little quick afterburner run here. Now, this is not as loud as real life, believe it or not. So, but those of you who have been around jet engines, especially military aircraft, you'll understand that it's not only very loud, but it's also very dangerous. So we certainly have to go through a lot of safety briefings with the team and make sure everyone knows what their job is and that everyone's in position, and take all the precautions to make sure you don't do something silly. Now, one of the things we just recently put together was an agreement with the LeMay's America's Car Museum down in Tacoma. They want to partner with us to get us on display in some significant locations. So the Seattle Auto Show is one, and then the next one should be the Detroit Auto Show. And we pretty much have our pick of other shows if we want to go to New York or Montreal or others. So that's really kind of an enticement to get people to want to support us financially. So if we can get their name on the side of the car as a title sponsor and take it about and show the car off. And so there's some significant shows that we expect to be in this coming year. Then back to the olden days. Before we built this one, we had this hand-built thing. And I call it a thing because it really wasn't safe over 300 miles an hour. But Jay Leno didn't know that. So you'll see us in this one here. We went out to the Mojave Airport and took Jay for a little ride. So this is a really fun weekend. I think you'll like this. And of course, this became a part of their show. And here's Jay antagonizing my grandson. We're down at a display at the Motor Books Aero in Burbank, and so he came by with a couple of steam-powered cars and hung out with us for a while. And yeah, Jay's really been a good friend with to the project. So actually, I'm hoping to get a young lady on his show, and we'll talk about that in a second. Here she is, Jessi Combs. One of the things that we discovered along the way is that Craig Breedlove's second wife holds a record at just a little over 300 miles an hour. So she is officially the world's fastest driver of a car. And Kitty O'Neill holds a record at 512 in a three-wheel car. So she's officially the fastest motorcycle driver. But we figure we can do the mid-500s with no real trouble. So we'd gone through several drivers that we thought we could possibly put in there and take the female record. And so we finally settled on Jessi Combs. And so she's kind of in training right now, learning how to start the engine and shut it down. And then we're taking her out to Bonneville in a couple of weeks and put her in one of our land speed cars and give her some more time. We put her in an open cockpit aerobatic biplane and sent her up for an hour's worth of aerobatics, and she loved every minute of it. She's a Baja racer, has raced there, I think, 8 or 10 times. She's podium finished twice. She's a welder, a fabricator, a mechanic, and a TV host on several shows. One is called The List, the Overhauling with Chip Foose, All Girls Garage, Extreme 4x4. Those are 4 of them I can think of. Oh, and she had hosted on Mythbusters as well. So we found that she really blends in with the team. She's a real down-to-earth person. And so we're really kind of excited to have her on board as our official women's driver. So hopefully this fall we'll have her out there running some pretty significant speeds as well. So if going to some of these shows doesn't attract a sponsor, you would think this would work, but who knows? We've been at this since the 90s, and we still don't have it. So, but anyway. So then we have a little movie teaser here that a film company's been following. So is this the same one? Yeah, film company's been following us around for about a year and trying to capture things and trying to put together what they want as an exclusive, but we're reluctant to sign an exclusive because that means they get all the film rights for free for the rest of our lives, and I didn't want to do that. So we're willing to negotiate a deal, but here's a little teaser they sent to us based on some footage that they captured along the way. Yeah. Thank you for your patience, and if you guys want to join us, we certainly can do a little Q&A, I think, if we have time. Yep. Do you have any time? Sure do. All right. Okay. Sandy has a question. So why are you doing this?
1 second. Let us bring the mic to you so we can make sure we get it on record. Hold on 1 second. There you go.
Well, a couple questions. One is, how much gas are you using when you were down at Shelton and you showed us the afterburner? In 1 minute's time, just standing still, how much gas are you using?
If we left it in the afterburner for 1 minute, we'd burn 160 gallons of kerosene.
Whoa.
Yeah, it's not
Can't-
very fuel efficient.
Yeah, yeah. And the other question is, you said the brakes were separate, but when you're going that quickly, and I know you've got parachutes and other things, does that mean you have to put both feet on both?
Well, the sequence for stopping, of course, is I pull the throttle back to idle. Okay? And so you'll immediately start feeling a slowdown. Then I reach up and I poke the one button or the other for left chute or right chute. So I deploy one parachute, and then you kind of get the feel that it has opened properly. You don't feel a lot, but you'll feel the thing be tugging. And then you also roll back with your thumb. There's a switch on the top of the throttle button. You roll that, and then that opens your speed brakes as well. So you do those simultaneously. And so you get that done, and then the thing starts slowing quite rapidly after that. And then if you feel that you want to, and I just apply both the toe brakes on the 104 the same as in the airplane. So you just roll those on, and then those magnetic brakes take over. But at the same time, I have sensors that tell what the temperature of the brake rotors are. And once they reach over 300 degrees, then I flip a switch that dumps water on the brake rotors and cools them off. If the temperature stays up there, then I just lay off of the magnetic brakes. But you'll slow down quite rapidly then. We found with our graphs, using our global navigation system, that our rate of acceleration and deceleration are almost identical. So you can pretty much graph your run so that we'll hit our peak mile right at the middle of the entire run. So that's what we've been looking for, is to make sure we could do that.
Other questions?
At high speed, do you have to use the canards to keep down pressure on the nose?
At this point in time, we have not been using them, but we're calculating the pressures using CFD analysis. And we may set ourselves up with an angular change if we need to. It's set up so we can put an actuator device in there to change the angle if we need it. But right now, we've been running at a fixed angle of attack on that.
Okay, now do you go by feel or is there a pressure gauge?
We have pressure gauges.
Okay,
Yeah.
thank you.
Got a question up front here. Here you go.
The wheels. With all the high-tech materials that we have today, is there a reason why you chose what you chose?
Mm-hmm. Well, I think we started off with, we had some billet wheels that we had built, and we found doing finite element analysis. One of our team members, John Mitleiter, is a physicist that works for Boeing, and he works in the department that does all the analysis of spinning devices and energy storage and that kind of thing. So he did the FEA on those, and he says, you're good for 600 miles an hour, and then they'll break into 3 big chunks. So he said, you don't want billet. So what we had to do is we had to get radial forged blanks. And so there's... Yeah. But so there's only 2 companies left in the United States that will do that. One is down in Santa Ana, California. They happen to also be the same company that builds the blocks for top fuel dragsters and that type of stuff. But they have the resource to build really high-end aluminum products. So they did the forgings, and then a combination of a couple of companies. Eagle Machine up in Canada does most of our machine work, as well as Euromet, a company down in California. They build about 90% of all the roller coaster wheels in the United States. Those 2 have worked with us to do the actual machine work and the things like the cryogenic treating and the heat treating and all the other things that go into that. But it took us about a year to design and build the wheels. But we've run quite a few runs on them so far, and with really good results. So we're pretty tickled with the way that's turned out.
Thank you. The other question is in regards to, as Richard Noble contacted you just to give you good luck, or is he like giving you a bet that?
Oh, no, we talk to those guys all the time. They're all good guys. That's the one thing that's kind of interesting about the land speed racing community, unlike NASCAR and drag racing. We're all equal competitors, and we all exchange information. We'll hold back a little bit of stuff, you know. But, you know, we'll go out drinking beer together. In fact, one evening, Andy Green was down at Bonneville, and he called me up, and he says, hey, we're going to be down at the Black and White tonight. You want to come down? Oh, of course. So we went down there, and it's amazing how much beer a guy from England can drink. But, yeah, those guys, you know, they're not as bad as the Aussies. But they can do a good job. But no, we're really good friends with those guys, and, you know, it's kind of a mutual admiration society in a sense. No.
One right back here.
How do you keep the nose down? As I'm looking at how much weight you must have out there or something.
Well, we had to do a lot of calculating along the way. We started off basically at the University of Washington. Professor Breedenthal, he did some fast calculations up there at his department, Aeronautical Engineering department. And he said, well, you guys need to have about a negative 2 degrees angle of attack, 1.5 to 2 degrees. Any more than that, you'll dig a ditch. Any less than that, you're going to fly. So we took that as a baseline. And then in addition to that, the angle of thrust on the engine in relation to the angle of attack of the aircraft is a negative 5 degrees. So it tends to plant itself all the time. Again, you know, you have to be careful you don't get too much downforce, because then you have other issues, such things as wheelbarrowing and that kind of stuff. So what's happened since then, using CFD analysis, we've been able to really, you know, validate that theory. So now with CFD, it looks like we're good to go for significant speeds and not, you know, go through the fear of flying. So computers are wonderful when they're working.
Ed, what's the tolerance of the vehicle on land? I saw you, you know, in the video, you lifted up some sand and it looked like it was quite grainy and fine, but how do you ensure that that is flat? And I guess you're looking for very solid land. And how do you ensure that?
Well, a lot of it's an educated guess.
Plus, we made our own.
Steve's,
We made our own.
We made our own.
tester.
Yeah, we made an impacting tool. Steve, you know, put his brain to work one day, and we said, okay, we can go to these different lake beds. We can figure out what the hardness is. But he designed this tube with a tube inside of it with a lead weight, and then you have graduated measurements. And we go to different locations, and you raise this thing up and drop it like that, and then we would measure how much imprint it would make. And so we did this at various locations, El Mirage and Edwards Air Force Base and Black Rock Desert, and then out to the Outboard Desert. El Mirage was really a good surface, but it's too short of a course. I mean, we only had about 5 miles max out there, and that's where we lost the parachutes on one test run, and I wound up about 50 yards from the end of the lake bed by the time I got it stopped. But we tested the magnetic brakes, and that was good, because they worked. But we decided to no longer run there. Edwards Air Force Base was a really good surface, but there's places with a lot of fissures and so on from weather-related conditions that just really prohibited us to run on any more than about a 6-mile track. Although with work, you could get 11 miles out there. And it had a beautiful surface. I mean, that would have been a really ideal location to run. But again, you got the government, and you have bureaucracy, and you have the U.S. military, and we finally gave up and said we can't run there. We ran at the Black Rock Desert. We measured that, and that's the worst of all the conditions. It's too powdery, too soft. I mean, you know, the car would sink in 4 inches into the dirt. And then it had hard spots and soft spots. There are places where they actually saw where my tracks left the ground on it after going over a lump out there. So at 300 miles an hour, you know, if you wind up flying it, there's no way to land it properly. So we decided against running out there anymore. We did, 3 different test sessions. And even the last time we went out, we tore panels off the belly of the car from just, it's a bad place to run. Beautiful. I mean, there's 22 miles or more than that out there available to run on, but it's just too bad a surface. Outboard Desert was probably the best considering all the conditions. Although we can only get 10 miles there, But the surface is really good. It's very smooth. You don't even have to drag it. At Black Rock, we would drag it with a big beam just to smooth it, but even that didn't help. Outboard, we can pretty much just run, whatever you see out there that Mother Nature gave us. So yeah, it's kind of a long story for the question, but that's kind of how we had to calculate it out.
Other questions? We got one up front. Okay.
The October Oregon dates, are those open to the public?
Yeah, pretty much open to the public. There's no place to stay around there, so you kind of have to bring your own tent. But yeah, it's public land, and we stay at the Outboard Ranch as far as the team, but our pits are set up on the Outboard Ranch property, but it's also on the lake bed. And so, but yeah, you can come out there. If anybody comes out, just check in with us, and who knows, we might put you to work. So, yeah, don't.
So once in a while, we have volunteers stand arm length and walk the entire length of the track and pick up anything larger than a nickel.
Yeah, Tessa, you were doing FOD walks out at Edwards Air Force Base. We found airplane parts. We found shells from
empty shells.
Yeah, all kinds of things. Yeah. And then they weren't seashells; they were shells. But yeah, if you do come out there, we'll probably put you to work. So.
Any other questions?
Anything else? Good. I think we covered it.
Thank you. On behalf of the Museum of Flight, thank you for being here. If you have not seen the vehicle outside, or even if you have, head back out there and see for yourself what a marvel this thing really is. And then I'll make sure I talk with them that when they break the speed record, maybe they'll let us borrow the car for a while and put it on display somewhere here. So we'll talk about that, though. Thanks very much for coming, ladies and gentlemen. Appreciate it.